Hello, everyone. My apologies for not being capable of attending the conference and presenting my paper or in person, physically being there. But I was prevented by my university to travel abroad. So this is in fact the solution that was made available by the organizers, and I thank Matty and all his team for making this possible. So my goal is to present a view into mobile communications in roughly 10 years from now, in the sense 2030, meaning what are the challenges and also what are the topics that, let's say, I would put it in a way that are very hot for research. As you can see, I will start by providing a few examples of other technologies, basically putting or looking at the past and seeing how it has been done in other technologies, and then putting into all of these into context for the systems and networks that we currently have and we see that can be made available in the near future or not so near future, and then extrapolating all of these to our area, mobile and wireless communications, and then some conclusions in the end. Okay, so you will remember computers, obviously, and the older guys may remember the mainframes and all these things of the past. The reality of these days is well known. We have smartphones that are much more powerful than the computers that occupied very large rooms and that were those that some of us, the older guys, used when we were studying. But besides the computation power, one of the things that made a huge difference for the reality that we have today was going from an operating system based on commands to Windows-like operating system. Meaning the easiness of use was really essential for the mass market. And the smartphones are another example of these, in the sense that people these days, they are used to the apps. It's much easier than having to go through a menu of what to other stuff. The other thing that we can learn from computers has to do with now, yes, with let's say, with the hardware and how to capture these hardware and make it useful for the software. Again, some of you may remember the ZX Spectrum. It was probably the very first computer made available to people back in '82. So a number of years ago, almost 40 years. And the clock was 3.5 megahertz. The RAM was 16 kilobyte, and it had no hard drive. The hard drive was a tape recorder. Uh, Things have evolved a lot since then, but what we have seen is that there has been a race in between the software used by computers and, on the other hand, the power, the computation power that computers have. And what we are seeing in wireless communications is exactly the same thing. Is a race between the data rates, the apps and the services that are made available after the networks and the terminals have a certain transmission or a power or data rates power or whatever you want to call it. So this means that in fact the resemblance is very large, and we need to be prepared for these for 5G and whatever comes late. On a completely different topic, we can look at cars. And cars, we saw that in the beginning, the goal was to have a faster car. Then cars developed for having comfort and safety as a key issue. And these days, cars are being sold for energy efficiency. And the bottom line here is that the speed of the car is no longer important. You cannot drive a car more than 500 kilometers per hour, to say the least, right? It's even not that. Of course, it's 100 something. So why should we start continuing to develop cars to go fast? We don't need them. That's the truth. Speed is no longer important. And this means that we will reach a stage in mobile and wireless communications in which speed, meaning the data rate, will no longer be important. And 5G already goes in this direction. We see already that latency and capacity are becoming a key importance factor in 5G. And that's exactly the direction. Speed is no longer important. An ultimate example I bring to you are pens. Pens, the stuff we used to write. And again, you may remember, in the sense of seeing the movies and all these kind of things, that in the beginning feathers were used as pens. Of course, it all evolved. And then in the 19th century, you had metal point pens that start being used. This will vary just for a few people. And then Bic, many years ago, already in the 20th century, they introduced the ballpoint pen in plastic. And it's basically worthless, right? That's the thing. When you go to anywhere and they want to give you a gift, that they want to give you something, but it's not expensive, they give you a pen. So how can companies still make money out of pens? Oh, but they do. Montblanc is a very good example, because pens these days are luxury products. They are not writing things. And you can have other examples of these, like watches. So we need to be prepared to have a scenario in which mobile communications are somehow, when they become really something worthless in commas, of course, that everyone has, which is the case already, we need to find a way that we have products that come with these, that are luxury ones, and creating a lot of value out of something that everyone has. Okay, terminals have evolved, and of course, we know that these days we have basically three types of terminals: the phone, the tablet, and the computer. And we can expect to have many others, like they are already on sale, like the watch or the Google glasses and many other glasses that can evolve. These will have a huge impact as well on the problem of the terminals and the impact that it has on networks. Of course, this example here, I think, is not at sale yet, but you can see that although this, of course, is just for fun, you can imagine that in sometimes in the future, you have mobile phones incorporated in many other things, like you have watches or clocks, as you want. These days incorporated in many other things. You have clocks on radios, you have clocks on microwave ovens, you have clocks on many other things. So we need to be prepared for that, and also for the impact that this brings to the networks. The services that we have are those that, of course, we know what we have today, but we can foresee that 3D and holographic images can be one of the challenges for the future, and probably this will be the challenge for 5G. Of course, there are many other services like real-time ad hoc communities or prosumers, which means that people are not just downloading information, but they are producing and uploading information. And this makes a huge difference in concerning the networks. Augmented and virtual reality really seem to be, again, a killer application between commas for 5G, but you have other things that have to do with context awareness on many applications. So this means that if you look at these days some of the trends there, we have the disappearance of paper, meaning we have electronics, if I may, being used as support for a lot of information. And this thing of buying a newspaper on paper before we enter into a train is already moving to everyone entering the train and then starting downloading information, right? The news of the day to each website or newspaper you use. And this means that, again, the networks need to be prepared for these. Another example is location awareness. That it's very common, of course, that with smartphones we know where we are, but we need to be prepared for the networks to take advantage of us where we are, meaning using terminals as sensors, and based on these, anonymized, of course, no one cares where LuisM Correia is, but the network may use my information of my phone to estimate channel quality, user behavior, and together with artificial intelligence, use these techniques to have a better perception of what's going on, and then, of course, the network, preparing the network in advance for providing better services. The Internet of Things, of course, is another one, and we can see that in the future we'll have a lot of sensors on clothes and all these kind of things. That is already somehow being foreseen in 5G. But the problem here, let's call it a problem, is that it is essential to differentiate between human and machine traffic. And we really need to do these for obvious reasons, because, well, we are different from machines. That's an understatement, but means that the traffic and the characteristics of the traffic are really different, and the networks need to take this into account. So, as you see, my view is that networks really need to differentiate these things. We need to put intelligence in the networks so that they become aware of the difference in between the types of terminals, the type of users, and all these kind of things, which is not happening today, and it's not foreseen yet, at least, to be happening in 5G. Vehicle communications, of course, this is said to be also one of the major areas for 5G, with autonomous vehicles being one of the key cases. And again, vehicles need to be looked as terminals. We can put a lot of antennas on the top of a roof in a vehicle, right? Taking care of the design of the car, obviously, but this is already happening with the phones. No one sees the antenna on a phone these days. The antennas are hidden inside the case of the phone. If you look at the first mobile phones, we had to pull out the antenna, all these kind of things. The problem for, let's call it the problem for vehicle communications, is that services need on vehicles vary a lot, from people downloading files via the terminal in the car to, again, to autonomous vehicles and many other things, radars, all these kind of things. Body area networks are very much connected with the sensors on the body, but then we need to go beyond the medical applications, which are usually the ones that are usually foreseen, and we need to extend it to well-being, assisted living, and entertainment. And entertainment is something that all of us are always are always available to put a lot of money. Remember these. So, and these are completely different requirements from medical applications. So we do need to take this into account. Let me show you now a few products that you can buy on the internet. This is so you can see how these things evolved, and some probably you don't know that this is already available. This is a jacket that you see that you can have on one of the sleeves. You have an FM radio that you can tune in. So you can go to the snow, you just dress this jacket, and then you just tune your FM radio and you hear music. So of course, this means that you have a lot of electronics already embedded on the clothes, or in the clothes, better. And having a phone embedded on clothes after this is just not even a technological challenge. This is on sale, so you can buy it. Go to the internet and buy one. The next one is something that Nike had an agreement many years ago with the iPod. Of course, there was a connection between the sneakers and the iPod, which would count the steps and this kind of thing. So having this doing these days, connection between shoes and a smartphone, of course, is not a problem, not that much of a problem, of course. This is a backpack with solar panels, so you may go to the middle of the wilderness, and you don't need to be concerned about not having a possibility to charge your terminal, because you can do this by charging your terminal via a backpack. But there's even a better solution, which is if you buy this jacket. And this jacket, you have the solar panels here on near your neck. So see, even a jacket like this, you can charge your terminals. And these are examples of things that you have already available. So you see that embedding electronics in clothes, in everyday objects is already there. It's a matter of more sometimes of a market, the existence of a market, and the price of these products, miniaturization of technology, and all these kind of things, rather than if we can make it. This is a phone call. I'm not sure if it was the first one, but probably it was one of the first anyway. A holographic phone call that was made in 5G with Orange and ZTE in the global 5G event in Valencia last year in June. So you have here a photo of the stage, in which on your left you have an holographic view of someone real life physically on the stage on the right. And this was a phone call. See, so it already happened. You already had an holographic phone call, full size, happening using 5G. So whatever comes in 2030 has to be better than these because this is happening already. Of course, I'm joking a little bit because the technology on stage was really astonishing, but okay, we need to make it smaller and cheaper for obvious reasons. Okay, smart cities, of course, put a challenge in here because they enable to have a lot of these services. So the final point here from this perspective is that the list of potential applications is endless, and the variety of requirements is endless as well. And the networks of the future need to be prepared for these. So let me, in a few minutes, address the difference between, again, humans and machines. But even if we just focus on humans, or some of the machines at least, this is what happens when you look at the daily activity of a network based on human usage. So people go to sleep during the night, after midnight, whatever, and then they wake up around 6, 7 in the morning, and then they go to work, and so on. Okay, this is fine. Now, if you just differentiate between voice and data, then it's different. You see that voice has that profile, and you can even see where people are having lunch. By the way, this is real data coming from Portuguese network, from an operator. You can see that in Portugal, people to have lunch around 1 p.m., but data follows a completely different profile. And the difference is that data, of course, on the one hand, you have machines doing data, which don't do voice. On the other hand, the usage we do of voice and the usage we do of data is completely different. And you can see that this is a usage of data in a location or in a part that is, let's say, much user related. I'll explain what I mean. Look at this one. In here, you have office in red, and residential in green. See, of course, in the residential, the highest peak of the traffic is during the night. During the day, people are working. That's where you have higher traffic in the office traffic curve. So we need to take this into account. And then if we want to distinguish between the different types of data services, which are all these curves, it doesn't matter really which one is which. What matters is you see completely different profiles in between the various applications. Networks need to be optimized for this if you want to use the resources properly. So we come back to this problem of the operators. The operators have a problem, which is, of course, we are paying less per byte that we transmit. So revenues is basically stabilizing, saturating, whatever. And then traffic is increasing because we are using more and more traffic because of videos and all these kind of things. So how to break the laws of physics? Meaning, what can we do? So obviously, the current perspective that we have, which is one size fits all in the networks, cannot be used anymore. We need really to kill, allow me to say this word, the era of voice-centric networks and start differentiating a lot of the services that are there. So this means that using this perspective, the Olympic Games, which is more of the same but just better, cannot be used. We need really to make disruptions. And I think that what we need is to use JFK's perspective that he said in 61, many years ago, that he wanted to put a man on the moon. And then, guys, do whatever you need in technology to achieve that goal. And I think that's what exactly we need to do in mobile and wireless communications. We need to have a goal and then just develop the technologies for that. And this means that what are the things that you need for 5G is no longer voice quality differentiation or data rate or capacity or latency. It has to do availability, intelligence, terminal sharing, I don't know. And this also goes to this graph that I have here on radio interfaces. See, space is not used as a part of the radio interface access scheme. Access schemes have been based on time, frequency, and code, not in space. 5G is not even doing that, although we start having beamforming, so we need to do this. So I think that truer trends are these days a a new radio interface, the use of higher frequency bands. We need adaptive antennas, cloud and edge networking already here. Flexible and adaptive networks clearly should be the case. We need to look into regulation and standardization and be aware that if you go outside mobile and wireless communications, then we have other bodies we need to account. We need to be careful with the ethics part, not just data, but many other things. If you are going to put sensors on bodies, biology and medicine here play a role. And we need to be aware that basically security and privacy keeps being a very important part, and the development cycles are different in many other places and sectors, economic sectors. And this means that we need to take them into account. So I'm ending my talk. 20 minutes have passed. And basically the key message here is that I think we should look at other areas which enables us to have some perspectives of the future of mobile and wireless communications. The evolution of services really need to be looked at when we want to look at the changes in systems and networks. And I think we really have still a lot of research challenges open for 6G, 5G is already there. So I'm sure you know these quotes. I like the last one very much. The best way to predict the future is to invent it. And with this, I close my talk. Thank you very much for attending. And again, my apologies for not being capable of attending the conference in person. Thank you very much. Bye-bye.